Okay, this is the more information about Space Habitat event. Then we yesterday was happened the presentations in Portuguese, and then now we finished the first panel, okay, about management and communication, and now we have a panel about energy, okay. Just a moment.
Okay, excellent. Okay, good morning, good afternoon, everyone. My name is Eduardo Salazar Perez. I come from the National University of Mexico, and today I will be presenting the first proposal for the development of a power station in settlements that will be located on planet Mars. This is a development of a work developed during the 56 missions and the 40th mission of a Habitat Marte. Okay, let's begin with the presentation. In order to maintain a good state of health of our habitat in planet Mars, we will need to have a specific power stations, and we will need to supply electric power to the different centers, such as the launch center, and the most important ones I personally consider the genome facility, the greenhouse, as well as the sanitation and the health facility. All of these stations will need electrical power in order to function properly. Therefore, I am considering personally taking into account the model that was developed by Jacques Rato during the missions 47 and 48. I will be taking his ideas in order to develop this power station. These ideas are derived with the idea of having multiple sources of energy in order to supply the stations with the energy they need in order to function uh, as properly as possible. Well, let's go with the internal design. Basically, the proposal is based in the idea of creation of a space habitat with a three-floor habitable area. We will have the following needs. We need a dormitory, specific areas for kitchen as well as for dining, specific areas for toilet needs, as well as a vertical garden in order to produce food as autonomously as possible and in order to be functioning correctly in case of a pandemic or any situation that involves isolating these stations completely. So let's go with analyzing in every floor of this design. Well, the first floor will be used in order to be used as a work zone. Therefore, this one will have zones for power monitoring as well as communication, operation, and control. These zones will be monitoring every one of the plants, the kilopower plant, as well as the uh, wind energy plant, solar plants, and many other plants that our energy station will have. As well, we will need specific areas for laboratory for research development, as well as maintain materials of maintenance of new devices. For example, sometimes our panels will stop functioning, our windmills will stop working. Therefore, we will need a specialized facilities in order to be able to repair these materials. As well, in order to be able to perform specific extravehicular activities, we will need an airlock in order for astronauts or cosmonauts that will be on planet Mars for them to live to the areas and to the specific maintenance works for the areas around. Secondly, we will have the second floor. This will be used by a multiple use zone. It will have specific zones for cooking as well as developing new techniques for cooking and preparing meals. Secondly, it will have a vertical gardening so as to obtain food and will and to be sustainable in order for us to have our own food and not only be depending by the greenhouse or the main stations or other stations, so as the astronauts can feed themselves as autonomously as possible. As well, this station is considered to have a specific zone for special gatherings, reunions, dining, as well as social interaction. This is very important for astronauts to keep the morale high, as well as having good relationships between them and the other astronauts that will be located in the Mars station. Finally, in the internal design, we are considering a third floor. This is considered for specific zones as a rest zone, as well as exercise. These zones will have specific zones for sleeping, for habitation of astronauts, and we will need to consider that these zones will need to be isolated and insonorized in order for them to keep privacy and do their specific activities as well as sleeping more comfortably. Secondly, it's important for our astronauts, for the people who inhabited these habitats, to do exercise in order for them to stay healthy, prevent muscular and bone loss. So we will need special devices for exercise. For example, the image you can see in the center of the screen. This is This is one of the Italian astronauts located in the International Space Station, showing us one of the devices they use for exercising in zero gravity. We will need to develop a specific exercise devices that work on the low gravity conditions that are present in Mars. And very importantly, these specific exercise devices can be used for the energy generation and harvesting in order to have extra energy for our station to work properly. As well, it will be very important to keep sanitations of our astronauts. We will need to design a specific toilets as well as specific showers or methods in order for astronauts to keep themselves clean and more comfortable as possible. Let's go with the biggest section of our proposal. We will be talking about applied technologies. So, in our applied technologies, we are taking into consideration the energy sources we will be using for our station. Personally, I consider four kinds of power that will be useful for astronauts to use during the travel to Mars, as well during the settlement of them in the red planet. Well, let's go with our energy sources. I consider four, which is wind, solar energy, hydrogen energy, as well as nuclear energy. These have multiple methods, and I will be explaining very briefly some of the uses of this kind of powers when people are settled in a lunar or Mars base. First of all, I would like to talk about the solar. This is one of the most considered kind of energy in order for them to be used in Martian or space facilities. Basically, the by propulsion involves using solar panels in an array in order to harvest energy from the sun. But we will have to take some considerations. First of all, is that we need to have higher voltages in order to minimize the resistive losses that we will have after harvesting this energy, as well as after having to transmit this energy to the other stations or to any other facility that will be located on Mars. Other considerations that we will have to take in account is that the intensity of the solar energy that we will be receiving on planet Mars is much lower because we have a greater distance from Mars to the Sun than we have from Earth. As well, we have to take into consideration the suspended atmospheric dust that is in Mars. Mars is basically covered with regolith. This regolith will be affecting the behavior as well as the efficiency of our solar panels. So we have to develop specific methods to clean and keep the solar panels completely clear and free of dust. And as well, the deposition of dust on the arrays will be an important factor to take into consideration when having a solar panel array in planet Mars, in the moon, or in a desert. Secondly, wind has been considered as an option for harvesting energy in planet Mars, but this will not be the first and principal source of energy. It is considered as a tertiary power supply in a primarily nuclear mission. This kind of energy will help us to enhance the safety and reliability of our station. Uh, there are many considerations that we will have to take in account in order to install a wind park or a wind energy installation in planet Mars. First of all, we'll have to consider the wind speeds. You can see the three values of wind speed. In summer, we'll have values between 2 and 7 meters per second. In fall, between 5 and 10 meters per second. And in a maximum case, In the dust storms, we will have a speeds of up to 30 meters per second. So, in order to generate electricity as efficient as possible, we will have to generate our turbines much bigger than the ones we have on Earth, taking in account that the wind speeds are much lower than we have on Earth, approximately one third of the speed we have of wind in Earth. Therefore, we will have to develop much bigger windmills as well as much bigger turbines so as to generate energy. Thirdly, we will have to consider one of our main sources of energy. In this case, we will take in account the nuclear energy. One of the ideas, there have been developments of many nuclear reactors. For example, the first one you can see in the upper side of my presentation, my slide, you can see the SP100 nuclear reactor. This was developed by General Electric during the starts of 70s and the 80s. It was a program from the United States. It was developed in order to work for space stations in lower orbit, lunar station, as well as Mars station. This had the possibility to offer up to hundreds of kilowatts of power, but it was depreciated at the end of the 80s decade, and currently the methods and the developments are being made so as to develop a kilopower reactor. This is also a nuclear reactor, which is fueled by uranium 235. This isotope is present in the 90%, as well as molybdenum in a lower basis, in this case 7%. This After that, we will know a nuclear reaction. It is developed by fission. How does this work? Well, basically one neutron is sent to the fissile material, the fuel, the uranium, and the molybdenum. This electron is directly shot to one of these atoms. Therefore, we are producing a basic nuclear reaction, the fission, and after that this fusion generates a great amount of heat. This heat will be transferred from the nuclear reactor to heat pipes, and this heat will be moved to a free piston Stirling engines. These engines will start to generate mechanical energy, and this motion will generate finally some electrical power. This power will be measurable from 1 kilowatt up to hundreds of kilowatts in the best case. By now, the kilopower reactor can generate up to 10 and or 20 kilowatts of power. Finally, one of the electrical power sources that I am considering in order to work in Mars is the hydrogen cells development. This can be used and obtained from local water or soil to supply electrical power and breathable oxygen. In this case, I am not consider a high voltage energy for this kind of power. This will be obtained for lower voltage applications, such as charging electronics or other devices that will need lower voltages. How will be generating these electrons or electricity? We will be obtaining by using hydrogen as well as an oxidizing element, in this case the oxygen. This will generate an electrical power through redox reductions. Don't worry. Okay, for our work, we will need also to consider the energy transmission. We will need to consider a high voltage alternating current system, as well as using some specific electrical power cables such as copper, aluminum, or copper aluminum wire to transmit the power in our station. Finally, it's important for these stations to keep a constant control and monitoring of the energy produced in the station. We will need to determine the works and the levels of energy consumption in each station. Let's go with the third part, which is the management, in which I am considering the final positions. We will need a specific position such as the power station chief, which will be the person that will be considered to keep a control as well as consideration for each station, and we will have the contact with the commander and the people who are in charge of each station. After that, we will have the chief officer of each station that will be specialized in the specific areas. After that, we will have the people who will develop the work of each station, such as the engineer that will be its operations will be specified for operation and safety, technicians that will be able to perform maintenance works, and the researchers who can be invited from other stations and also be capable of developing new devices. Finally, the protocols of safety will have to consider normal operation as well as energy operations. In a normal operation, we'll have a normal and specific works for our plant to function correctly, and emergency operations that will be used to consider in case of emergency, such as loss of energy, a miswork of one of our operations, and considering of evacuation in the worst case zone. Finally, I will want to present some of the spin-offs that will be generated by the development of this station. One of the most important ones to be used on Earth is the use of new sources of energy, in which we will take into consideration the research, development, and implementations of new sources of energy in order to obtain cleaner energies. This will take us to our final part, that is the impacts to sustainable development goals. One of the most important ones we are considering for planet Earth is a number 7, for the people to have affordable and clean energy regardless of their situation or the place where they live. So if we are considering bringing energy to other planets, to other surfaces, we will have also to consider bringing energy for other people who live on Earth. This will also have an impact for quality education, development of innovation, industry, and infrastructure, and finally, and most importantly, for climate action. Okay, this is my presentation, my references, and my contact in case you want to have a contact with me. These are. Thank you very much for your attention.